The Linux architecture. The architecture of a Linux system, really any and all distributions of Linux, is relatively the same. Almost all Linux distributions come with a core similarity, which is the Linux kernel. On top of the kernel is the part of the operating system that most of you are familiar with, that users actually interact with on a daily basis, and that is the user space. Within the user space, that is where all of your applications and programs usually lie. For instance, the shell on a Linux system is just one of hundreds and hundreds of applications that you can use on a Linux system. But that application is operating within user space or user mode. In order to actually talk to the kernel, it has to go through what we call a system call interface. There's multiple different system calls that allow applications to talk to the kernel, request resources from the system like memory, or to start a process, or access file space, start up a network socket, send data through a network or across the network. There's multiple different things that an application might want to do with the hardware of the computer. And in order for an application to do that, they have to talk to the kernel through the system call interface. There's two main different types of programs that run on the system within user space. That is, system programs, those are going to be your system services, things like your SSH daemons. We typically in Linux refer to services or system programs that run constantly and provide some sort of service to clients as daemons. So system daemons will be things like your SSHD or an HTTPD web service or a web server. Those would be system programs. Also, on the other side, we have applications. Applications are going to be things like the Bash shell that we've been using already, or gedit, maybe a Firefox web browser. Those are user applications that we will use, and although they do run in the same space as system programs and services like daemons, they have different functions and they serve different purposes. A little bit more about the kernel. The shell versus the system call interface versus the kernel. So we know the shell operates in user space as an application, and it talks through the system call interface to the kernel. Now, one of many different things that a kernel can provide to an application, they include managing files on disk or accessing data that's on disk, or writing data to disk. For instance, when you open a text editor and you're typing text into that editor, the way that it is saved to the computer is it talks through the system call interface and asks the kernel to write data to the hard drive. The kernel also takes care of scheduling or starting processes. So when we want to start a process on the system, for instance, when we want to start the Vim program to open up a text file, we request through the kernel, through the system interface to the kernel, to start or schedule that process. The kernel will then take the binary executable file for Vim and execute it and load it into memory so that we can utilize it. From there, the kernel also manages memory and manages resources and space within memory. If you want space within memory, or your application does, it has to ask for it through the kernel. The kernel is also responsible for transmitting and receiving packets across the network. So not only do you have to go through the system call interface to the kernel to request to open a network socket through an application like Firefox, but every single time you send a packet across the network or onto the internet, it has to go through the system call interface to the kernel and request that that packet or that data be sent through that network socket. Lastly, drivers that are loaded and typically referred to on Linux systems as kernel modules. They're very similar to the functionality of DLLs in a Windows operating system. They're called kernel modules, and those typically will provide a lot of the driver's information that the kernel needs to talk with the hardware on the computer. The only way that the kernel understands how to talk to the hard drive or how to store data on the hard drive or write data to a hard drive is by understanding the language of the hard drive. And that language it learns through drivers, which are simply just applications or programs that run in kernel space instead of user space. And that is the basic architecture and how the whole system functions within Linux.